Welcome to Oceanic and Polar Experts. In this episode, we're thrilled to feature an interview with Professor Tingzhuang Yan from Shaw University. Professor Yan holds a PhD and a master's degree from North Carolina State University, along with a bachelor from Nankai University in China. His research focuses on numerical and statistical modeling, data mining, prediction methodology, and climate change. He is a winner of the Best Data Sources methodology in DARPA's Forecasting the Spread of Infectious Diseases competition and a recipient of the National Research Assistantship at NOAA's National Climate Prediction Center. Today, Professor Yan will share insights from his research and his academic journey. Get ready for a dive into hurricanes, computer science, and climate change. Hi, Professor Yan. Can you tell us a bit about yourself and what you do?
I was born in Qingdao, China, graduated from Nankai University in 1983. So after graduation, I worked 3 years at a computer manufacturing in Tianjin, China. In 1989, I got a master's degree in physical oceanography at the Institute of Oceanography, Chinese Academy of Sciences. So in 1999 and 2006, so I got master's degrees in computer science and a PhD in atmosphere science at North Carolina State University. In 2007 and 2008, I worked at Climate Prediction Center as a visiting scientist, and back to North Carolina State University as a postdoc fellow. So from 2010 to 2016, I worked at School of Coastal and Marine System Science, Coastal Carolina University, as a visiting scholar and adjunct assistant professor. Okay. So from 2013 till now, so I teach computer classes at the School of Business and Professional Studies at Shaw University, which is a HBCU university, okay, as assistant professor of computer science.
Many of your publications are on hurricanes. How did hurricanes grab your interest?
So hurricanes developed in the North Atlantic Ocean basin can impact the entirety U.S. coast. So from Texas to Florida and up to northward Maine. Okay? So there is considerable demand for a seasonal hurricane landfall prediction for the United States. The storms that most people really worry about are those hurricanes that actually make landfall. So in my PhD dissertation and a series of papers published in the period from 2005 to 2015, I presented new methodology for selecting predictors to predict the overall North Atlantic tropic cyclone activity, and also the number and the possibilities of hurricanes that would make landfalls along the U.S. eastern seaboard and the U.S. coastline of the Gulf of Mexico. My analysis of the two-dimensional climate, oceanic, and atmosphere data and their correlations with North Atlantic hurricane activities provide a new way to identify hurricane-related climate factors. During my PhD study, I developed a seasonal landfall prediction model for the United States. Okay? And a set of mathematical models applied with this methodology was tested and showed excellent handcasting skills for the past 6 decades. And use this model, I have successfully predicted landfall hurricane numbers for the U.S. East Coast and the coast of Gulf of Mexico during the year from 2004 to 2016. Key to this new methodology is the assumption that landfall hurricane distributions not only depend on the overall hurricane activity, but also on specific hurricane track related climate parameters.
What are some interesting findings in your research that you'd like to share with us?
Using the pre-simple component analysis of North Atlantic hurricane track density function. So I found 3 important dominant empirical orthogonal function modes. Okay? The first mode represents the overall North Atlantic hurricane activity. And the second and the third mode demonstrate dipole structures, which are closely associated with hurricane track accumulated in the east-west and the north-south direction, respectively. So this finding provides an efficient way to pick up useful predictors for landfall hurricane prediction model.
How do you currently see the role of computer science in your field? How do you envision its evolution in the future?
Hurricane forecasting is considered a lot climate factors, okay, and process vast amount of data. So modern computer with faster processing speed and a larger memory and a huge storage can process more data with considerably faster speed. So more factors could be included in computer model to improve the prediction accuracy.
How do you think of climate change, and what should we do to respond?
Climate change is a growing crisis that affect many aspects of human life, so including many parts, okay, aspects, health, safety, food production, etc. So there are many ways we can respond to climate change, including using renewable energy, using less fossil fuels, and driving electronic cars, and restore forest and wetland, etc.
What do you think is needed for meteorologists and computer scientists to do to respond to the climate crisis?
So they can work together to create accurate forecasts and inform the public the consequences caused by the climate change.
You are awarded National Research Assistantship in National Climate Prediction Center (NOAA). Can you share with us what this award entails and what motivated you to pursue it?
The National Research Associateship program recognizes and supports outstanding graduate students who are pursuing full-time research in science, technology, engineering, and mathematics. So this program provides fellowship for individuals who have demonstrated their potential for significant research achievement in the field. So each year, only about 300 new graduates in the United States are able to get this award. Okay? It provides me strong support to work on my interested research field.
What is a common myth about your job or industry?
The job of a meteorologist is closely associated with people's life, so they should be respected. If you are interested in this field, you should realize this is not an easy job. Sometimes you may feel frustrated, boring, and compared to other fields like computers, the return may not be great.